let us do an MCQ based on tangents and congruency of triangles. Let us first start with the tangent problem. Now here there's a point A. Okay. Now we have a circle in this way where it touches the triangle ABC at P over here and at Q and R at this point. And this is the center of the circle O. Now you have been given that the perimeter of triangle ABC is equal to X. If this is given, what is the length of line AQ? 1. Is it X? Is it X upon 2? Is it 2X? Or 3? Is it X upon 4? Okay, now just going by the diagram, I don't think you can guess which one should be the right answer, right? We'll have to do some rough calculations or rough workings. Now we have to find the length of AQ in terms of the perimeter of the triangle ABC, which is given as X. Okay, so let us just write the value of the perimeter in terms of triangle ABC. X is equals to AB plus AC plus BC, right? This is what we have been given. Now applying the properties of tangents tangents to a circle from point outside the circle, we see that point B has two tangents on the circle. If you see properly, first of all, this one is very clear that point A has two tangents, AQ and AR, and they must be equal, right? So we write this information, AQ is equals to AR. We know this. But if you look closely, there are another two tangents, two sources of tangents within this bigger set of tangents, that is B and C. These two also are drawing tangents on the circle at points P and Q, right? The point B has a tangent BQ and BP, and point C has tangent BC, CR and CP. So even these two must be the same according to the properties of tangents of circle. Okay, so we write BP is equals to BQ and PC equals to CR, right? This is what we know. Now, how do we substitute or how do we convert this thing in form of AQ, right? To do that, first we need to convert BC in terms of BQ and CR. Only then we will be able to substitute the value of X in terms of AC and AQ. I mean AR and AQ. So let's split BC up in terms of BQ and CR. So we can write AB plus AC, and we can split BC up into BP and BC, and BP we know is, okay, let me not skip the point and just write everything clearly without skipping any point. So I'm splitting BC as BP and PC, right? And now I know that BP is equals to BQ and PC is equals to CR. So I will replace BP with BQ and PC with CR, and this I write as it is. So now what do we get? Now we have got AB, AC, BQ and CR. So I can combine AB and BQ to write AQ, and I can combine AC and CR to write AR, to form AR. So now I've got the equation in terms of AQ and AR. And I also know that AQ is equals to AR, so I can write X equals to 2AQ. And now I got the value of AQ in terms of X. That is AQ is equals to X upon 2. So 0.2 is the correct answer, right? So the only thing which was a bit tricky was to form this equation and substitute the values of BP and BC in terms of BQ and CR by identifying that these two also are tangents to this circle. Now let's do another quick MCQ on congruency of triangles and test your knowledge on that. Okay, it's a pretty straightforward question, that by which congruency is triangle ABC equal or congruent to triangle DEF. So now there are two triangles. This is, forgive my bad drawing. So this is A equals to 30 degrees, it's given, and these two angles are equal. And there's another, this is ABC, okay? Let me name it ABC. And this is 30 degrees as well. This is DE, and this is DEF. This is equal to this. Now, by which criterion of congruency does these two prove to be equal, or these two are equal by which of the following criterion? SAS, 2 is side angle, 3 is angle side angle, and fourth is none of the above. None of the above. Let's check each of the conditions one by one. Side angle side. Now this is definitely not true, because side angle side should have the angle between the two equal sides, right? So the angle between the two sides which are equal, the angle is not equal. The angle included between them is not equal. This angle is outside of both these equal sides. So this is definitely not true. Now side angle, right? Side angle. Yeah, this might be true. So I'm not eliminating this completely. Angle side angle means side should be between two equal angles. One side should be same, but here both two sides are same. So this is also definitely not true. None of the above. Now we have to choose between these two, and the answer is probably between these two only. Let's find out. What do you think? The correct answer is not this, but none of the above. Now let's find out why. This is because SSA, or side angle, which many students may have a question that why side angle is not a criterion for proving congruency. So this is none of the above, because side angle cannot prove congruency. And definitely in this case, these two triangles are not congruent. As you can see, the shape of this is not equal to the shape of this. So why is this statement that SSA cannot prove congruency? This is true because side angle can prove congruency of two triangles in certain cases, but in few cases, it fails to prove congruency. It fails to prove congruency, and thus it is not a proper appropriate condition to prove congruency. Just like in this case, you see these two sides are equal, and the third angle which is not included between them is also equal. But see, the shape is different. Why is this true? Let's just quickly find out. See, let's say I have drawn an angle 30 degree here, and I draw a side of length, let's say X, okay? And here again I draw the same angle 30 degrees. But here I can draw this same length by rotating it. See, this was the earlier length. If I draw the same line over here, these two triangles will be congruent, right? But what if I rotate this angle a bit and place it over here? Okay, if I rotate it and if I place it over here, this side and this side are equal, and even this side and this side are equal, right? But you see the shape of this and the shape of this triangle is quite different. So even though both the sides and one angle are equal or same, but the shape of both the triangles are not same, and hence this condition is not sufficient to prove congruency. Okay.